For those of you guys just joining us, we are still in section 6.1 notes. I went ahead and posted on Google Classroom that what I was specifically looking for homework number 36 was to have 75% attempt, because there are trickier problems and we're going back into our notes to figure out what those problems are. We will grade homework 36 tomorrow. 37 is not due until, I believe, Friday. So what we're trying to do is finish up 6.1 and get started with 6.2. We're going to go back in just a second to that example that we saw yesterday and how two cases were possible, and even think of a picture as to how that could possibly happen. But for right now, just looking at the math and just looking at plugging in this information, what's going on, whether or not you guys thought that it was whether two cases were possible. So as you went ahead and plugged in, I'm hoping that you guys plugged in to the formula sine of b over b equals sine of 42 over 22. Do you guys agree? Yeah. And if you rearrange that just a little bit, hopefully you ended up with the idea of b is equal to sine inverse of what? Well, I multiply both sides by 12. I'm going to multiply both sides by 12. But then how do I get to b with sine of b? Inverse of both sides. So I'm going to end up with 12 times sine of 42 all over 22. However, if there was a second case, what else would we have to consider? 180 minus the answer from above. This is what your calculator technically puts, I think, if you use second negative sign. So I'll use that as well. So when you guys went ahead and did sine inverse of, double check my answer that I'm right, 12 times sine of 42 all divided by 22. Did you guys get 21.6? Okay. So right now I know that 0 answers are not a thing, because at least one angle works according to the math. Because my calculator gave me an answer, 406. You guys concurred, so that's totally valid. We would also have gone ahead and done 180 minus that answer. I just go up and grab it. And we would have had 158.594. And if we hadn't, if you hadn't tried any homework, and if we hadn't talked about this just a little bit yesterday, most of you would have been like, all right, sweet, 2 options, let's go, solve, solve, solve. What would you have had to solve for next, like we did in the example? What would be something that we go? We would need angle C, not just one option, but both options. Here's my question. Is there a possible angle C for this guy? Yeah, totally. How do you find it? 180 minus 42 minus 21.406, or the longer angle, but either way you get 180 minus. And is there another third angle remaining? Yeah, totally. Did you guys get 116.594? But what happens over here? We have an angle of 42 that must be true. Sine inverse technically allows us to go first quadrant or fourth quadrant, an acute angle and an obtuse angle. But can this obtuse angle join together with that guy to make a triangle? No, it's impossible. Because 158.594 plus 42 is greater than 180. Johan, what's up, bud?
Did you say if you add 2 angles, it has to be bigger than the third?
Oh, 2 sides. 2 sides. Yeah. The angles, I don't think. You can have like an angle of 1 and have it just be like a really, 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 really long triangle. Does that make sense? But yeah, sides. So this one, if you were to not be thinking and just be plugging in the math and be like, okay, 180 minus that guy, the 158, there he is, minus the 42, and not be thinking about what those add up to and that it's more than 180. Why is it fine if you get negative 20.594? You can't have a negative angle in a triangle. I mean, have a triangle be formed from an angle gotten in a negative position, but the actual triangle is only allowed to have angles that add up positively to 180. Do you guys see how this is going to be an example of looking back at the ambiguous case? Oh, sorry, I only needed to go 2 pages. Example of that guy. So when is this true? When the math says both are totally legal and, well, hold on, let's finish this answer and see how this one was different. What happened when you started trying to find angle C? Okay, what'd you guys get for the first one, for the little acute option for angle B? Angle C was 125.247. Do you guys agree? Okay. What was the angle C for this guy over here?
14.753.
But long story short, and why this is a possible solutions, and we're going to have to give both because both are valid, is that both of these angles, sine inverse, or the one gotten by sine inverse and the one gotten by 180 minus sine inverse, both of them could add to 20 and get a third angle, add to 20 and get a third angle, make a possible triangle with this piece of information. Now you guys needed to use law of sines to find little c, right? So they worked on that. What was little c for the acute B? 1/6 what? And then for the obtuse?
2.234.
Okay. Now, I wanted to go ahead and show you guys really quickly with an illustration how this is possible. Because some of you are like, I don't get it. 20 degrees, 5 and 3, can't that only make one triangle? Do you guys see how I have my 20 degrees over here? I actually already made it with the protractor redo. I'm coming over here and I'm going to make it, unless my computer freezes, then that's kind of sad. Okay, Control C. All right. Now I'm going to grab out my ruler. And we know that, hold on, which angle is this? Angle A, right? Okay, so I have an angle A, and I have an angle A. How long are these lines? However long the protractor, because you can like do a protractor, spit out an angle. It's just whatever it spit out. It didn't know anything about that 5 and 3. It had no clue about those pieces of information. So I'm going to go ahead and say, well, hold on. 5, angle B. If you were to draw a triangle, let's go ahead and make side B be this guy. From A, right? But side B can be one of them, and I don't know about you guys, I kind of like making this bottom one still be the ambiguous guy, so I'm going to go ahead and make this guy instead be the 5. Okay, so I'm going to go ahead and follow my ruler. My ruler right now is being measured in, I think, centimeters. I could do inches. Let's see, am I going to get a good triangle? I think I will. Here we go. So there's 0, 1, 2, 3, 4, 5. Okay. So I measured 5. And I could do that for both, right? Go use the mouse. How is it possible for there to be an angle A of 20 degrees, for there to be a side of 5 that comes off of that angle A, 1, 2, 3, 4, 5, and a side 3. So I'm going to come over here to the side. Let's get our little ruler. He's being really obstinate right now, but that's okay. Let's go ahead and just make him flat. Let's do another color for A. And he's only allowed to be 1, 2, 3. All right, guys. How does this work? We have our 20 degrees for both. We have our 5 for both, being little side B, little side B. We have our side A being 3. How can I make 2 triangles? If I was to take this little segment and I was to make all these pieces for you, and as I take this little segment, Wouldn't you guys come up here? How do I make a triangle with a segment? What would I need to do? I know I had the bottom, because that makes the 20 degrees. I know I have the top. That makes 20 degrees. He can only go up to 5. What does this guy need to do? Somehow connect, right? He needs to swing. So if I was to take him up and if I was to swing him, okay, well, no big deal. As long as I swing him, which I can do, I can rotate this little guy and then fit him in. He just needs to connect with the bottom side, true? What case is this, the one that I'm drawing right now? Case 1 or case 2? I'm going to go ahead and come on in and finish this bottom side. Let me grab my ruler again. If I was to go ahead and connect these guys and say, ha-ha, I made a triangle. Look, Mom, I made a triangle. Okay, if I was to connect it, what is it, case 1 or case 2? How long is that third side? Is it the 7.163 or the 2.234? Yeah, how do we know it has to be the 7.163? But both of these are supposed to be valid, though. Work, because this guy plus that guy is bigger than that. It's a little back. They're both valid triangles. But how did I know it was 7.163? Look at the angles. What are all the angles? Well, this one was acute. And what's this one? Also acute. So if this is my B, I know this is angle B. And this is my C, that's angle C. C is obtuse and B is acute. That's how I knew. For sure, for sure. It's acute, obtuse. So how on earth do I swing it any other way? What if I go grab this? Because remember, I'm supposed to be able to make two triangles. That's one way of swinging it. But how do I swing it any other way? Does anybody have any ideas? Up? But as soon as we go up, guess what happens? Who don't I have anymore? I have to have the 20 degrees it was given. I have to have 20 and then 5 and then 3. Well, I don't get it. Isn't that the only way to swing it? What if I swing it to connect? Won't I make... Aha. What if I swing it in? Now what's going to happen as I swing it in? B is going to be obtuse, C is going to be acute, and my little side down there is going to be a whole heck of a lot smaller. Do you guys see it? This one is also a 20 degree 5, 3. What's true in this 20 degree and 5, 3? Now all of a sudden for my third side, there's no way it's 7 point something. Now it's 2.234. And my A, B, C. C is acute. Nope, where is he? There he is. C is acute and B is obtuse. It makes sense. So what's different? This one, you were able to make two different triangles. It just depends on whether you swung the other side out or swung it in. Without knowing either of these two angles, only being given one angle and two sides, it's always going to be ambiguous because it's like, well, I could swing it in or I could swing it out. So what's so different about this guy? Why only one case? Let's assume this is somewhat accurate. 42, it could be, right? 90, yeah, sure. 12, well, 12 has to be shorter than 22, right? Okay, could be. Why couldn't you swing this guy in? Isn't he going to be too long? Where would he swing in? Over here. And what happens to the 42, like you guys were doing a second ago, if you're over here? He's lost. So is there a relationship between when you're going to have two possible solutions versus one possible solution? Does anybody see a general way of expressing that? What happened to the sides here that made it impossible that wasn't true here? Yeah, Kyle.
Something was like,
Not line C, though. Line B. So if you're given angle A with side, the opposite side from the angle. So in this case, it was A. If it was like side C, like they could have given us different information. But whatever that opposite side, where A is bigger than B, how many cases are going to be possible? Only one. But when A is less than possible. Unless. Aiden and Jason, go ahead and just go stand in the back for a little bit. Just kind of shake it off. Take it like 30 seconds to a minute and then come back. Unless. What could happen if this side is less than that side? I'm giving you a warning. We're saying, yes, it can swing both ways, so too, but I'm saying, in there's also a 0 and there's also a 1. What am I talking about? Jason, go stand in the back just real quick. Shake it off. Same length? Ooh, if it's the same length, then it would be, it'd be 1. It'd be this case, right? Okay, so we have this side can be greater than or equal to. If it's greater than or equal to, there's only one case. If it's less than, it could be 2 or. What if it goes straight down? So hold on, think about it. Okay, think about this case real quick. If it was a right triangle, if I had 20 degrees, let's think about what the side would need to be. Because we're trying to find some sort of formula. And the book actually makes like this whole chart and expects you to memorize it. I'm like, phooey, that's silly. But 20 degrees and 5. What would this side need to be? Something less than 5, because the hypotenuse is the biggest side, but something less than 5, but only one possible way to connect. If it swings out, it won't connect. If it swings in, it won't connect. We'd have to do trig, right? So couldn't we use opposite over hypotenuse? Couldn't we use sine? Someone in your calculator, help me out real fast. I have sine of 20 degrees is equal to A over 5. What would A need to be such that this would only connect once? It would be too short if it swung out, too short if it swung in. It can only connect straight down. 1.71. So here's the struggle, guys. Trying to think through our different patterns. If A is greater than or equal to B, only one case. If A is less than B, 2 cases. Less than B and greater than. B sine of angle, aka greater than the right triangle side. What's going to happen if A was less than 1.71? None. You could go swinging all day and it's never going to hit the poor little line down there, right? So if A is less than B but greater than the right triangle side, okay, then 2. If A is equal to the right triangle side, well, then it's only 1. And then if A is less than the right triangle side, it's just going to be this poor little swinging door that can't actually hit. So 0. But how would you know that with the math? Because right now, oh my goodness, do we really want to like get sticks and cut all the sticks and then try it and see if it fits or not? Ugh, that would be annoying. I mean, it'd be kind of fun if you're in elementary school, but not for us. So let's go ahead and go look at this guy. I wonder what's going on there. I wonder if it's going to be a 0, if it's going to be a 1, if it's going to be a 2. Let's try the math and see. All right, if you guys feel awake, go ahead and sit down. It's okay. Thank you, thank you. If you guys want, you could even save yourselves some time and some effort to see which case it is by saying, I have 76. I have 20. We could solve for x and see how it compares. That's not degrees, that's silly. That's a length, huh? If you want, you can just use my work. I'm going to write it right here. What's the problem with x being 19.406? The right triangle being 19.406, the shortest distance between 2 points. What's going to happen to my poor little 18? Right? Can you see it visually? But try just plugging into the law of sines and see if you really, really, really have to visualize it like visually in a triangle. Just try plugging into the formula like you did for the other example and for the one that we just did. There was only one case. What happens if you try plugging in? You get an error. Wouldn't you just do sine of b over 20? No big deal. You do sine of a. I mean, that's what we've been doing. It's no big deal. Law of sines. You guys get why I'm orienting it this way, because my unknown is in the sign, right? So I put him on top. We would solve. No big dealio. B would equal sine inverse. I can even write it as an expression. It's gorgeous. See? 20 sine of 76 all over 18. I go get in my calculator fully trusting that every problem must have an answer, right? And I have 20 sine of 76 divided by 18, and I get error. Why? I haven't been forcing you to do this, but if we were to actually just do the inside fraction, which I think kind of wastes time normally, but right now I'm going to go ahead and do it. What's 20 sine of 76 divided by 18? Don't we get 1 point? Oh, why is that bad? Sine can only go up to 1. So do you need the picture and the little right triangle side to know that it's not possible? No, you could have just plugged into law of sines, just blindly being like, yay, let's go find the answer. Error. Ah, okay. What case is this? None. None. Can you get 2 cases? Yep. When? When little side A is less than B, but bigger than the right triangle side. It'll swing in and it'll swing out, and you'll get those 2 possible cases that are sometimes going to occur when given SSA or ASS. Can you get only 1? Yeah. If side A is longer than side B, it can only swing out. It can't swing in and maintain the integrity of the problem, that original angle. And if you try to do 180 minus, aren't you going to have some issues finding angle C? But can you also get none? Error. Dun, 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 dun. So, can I show you guys a chart real quick that the book gives? It's a snazzy chart. There's one homework problem I give you where the chart might help to look at or to visualize, where there's a lot of unknown stuff. I think I give it to honors and not to regular. Regular would kind of freak out if I showed them that. You guys will probably freak out too, but maybe you can think a little deeper about it. But do you see how they're trying to show what I showed?
Yeah.
If A is less than, look, he's going to just swing. Poor little guy, he can't connect. And if we tried to bring that up, didn't we just ruin the angle? If A goes straight down, if he's the right triangle side, well, it's only 1. He can't swing in or out and make a triangle. He can only go straight down. But if A is, well, greater than B, yeah, there's only going to be 1 way to swing. But if A is in between, can't it swing out and in and make 2? And they go into this whole obtuse, and I don't even know what that's for. The last 2 I think are kind of dumb. But these ones kind of make sense, and that's why I tried to show you with an actual example where this comes from. Do I want you to memorize this? No. I think plugging into law of sines is adequate as long as you check sine inverse and 180 minus sine inverse. I see Kyle checking out his homework spiral. You guys might want to open up because I think he's about to ask me a particular question. Go.
That's fine. That was the question for 35.
Ah.
Where do I find where?
Because they didn't give you numbers, right? Do they give you anything like an angle or whatnot on number 35? If you guys want to check it out, 35 is the nasty beast problem, I think, of this entire homework.
They give you numbers, 36 degrees and 5.
Ah, but they don't give you the last one, right? Okay. The nice thing is, it's a really similar to the one we just did, because we just had 5, but we didn't have, right, we didn't have an angle of 36, so it was a little bit different. We're doing section 6.1. If you guys want to peek at number 35, it's a gross, nasty problem. If you don't have it done up to there, go in the back of your homework spiral. Workspace, remember. We have options. Uh-oh. Come on, but go. So how are you guys? Doing all right? Anything else in homework that didn't make sense? Well, it's looking for number 35. Wasn't there something else they randomly started talking about that you're like, what? Where'd that come from? Okay. Write down the area formula in your notes while we get to number 35 to look at. You actually saw this formula, if I'm not mistaken, at least in Algebra 2. If not in geometry, you probably just forgot it. Because the area formula we like to remember for triangles is 1/2 base times height, but that only height. If you don't have a right triangle, who's the height? Dot, 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 the altitude that's not really written. Ugh. Which is basically derived from or found from using different properties of triangles. We could make a right triangle, use properties of, say, hey, 180 minus 102 would be the little angle in the right triangle. We could use this side as a hypotenuse. We could solve for the other side. We could get the height. It just would take a lot of work. So they're like, hey, instead of having to draw the little dotted altitude and then make a little triangle you don't know, using what you know, it says if you're given SAS, area can be easy. If you use sine, it's just a simplified form of the whole process that would be necessary to solve this, since it's not a right triangle. So it's 1/2 the two sides, sine of the included angle, or the in-between angle. So I'm going to go find number 35, and as I do, you guys plug and chug it. It should be pretty easy. You don't necessarily even need to memorize 3 different formulas. It's really just one. Given side angle side, it's 1/2 side times sine of the angle. Okay.
But they're all separate, right? So it's like it's the times. It's not.
Depending on. Right. Depending on what you're given, it's just this, not the 2. Well, this one is C. Sorry, angle C. This one, not the other 2. And you do 1/2 A times B and then sine of only angle C. Yeah, by itself. Let's see if it's done searching. There it is. Was there a funny problem in this homework too, like in the gray box? Or was 35 the nastiest one? I thought there might have been one other nasty one, like a gray box, but maybe not. 62. Okay. I'll be ready for that tomorrow. We'll just peek at number 35 for now, but I was thinking there was a couple other tricky ones. Okay, let's see how you guys did. So when you were plugging in, did you guys go ahead and just do 1/2 of 52 times 90 times sine of 102? It was as easy as plug and chugging. What'd you guys get? Awkward. Tony's going for it. That'll be 45 times 52 times sine of 102. Tony, what do you got?
2,288.
Good. I'm going to throw a few decimals in there. 865. However, what'd they give me? So I better put for area meters squared. Good. Okay. Area formula, we okay? Plug and chug? So let's go figure out what's going on in number 35. Okay. Number 35 gives us just an angle and a side, which isn't a huge deal. And if I wanted to be super snazzy, I mean, I could be super snazzy. I could go over here and I could actually grab out my nifty-difty protractor. And I could actually measure 36 degrees so that you guys believe me when I give you like a pretend angle. There we go. 36 would be one more, right? Pop it out. There he is. Okay, so now that I have my 36 degrees, they also told me, oh, what side is 5? The opposite side. That's where they got nasty. They didn't give you the side that goes along the angle. They gave you the opposite side, which is pretty mean. So I'm going to go ahead and get my opposite side of 5. 1, 2, 3, 4, 5. So here's the struggle. They gave me this guy. And they're asking me to make this guy either be, thank you. Either have, I think, is it 0, 1, or 2?
Yeah.
Ooh. No solutions, 1 solution, or 2 solutions. So they did not tell me what's going on with this little side. It could be long, it could be short. For sake of purposes, I'm going to go ahead and say, well, wait a minute, hold on. What would happen if this side, right, was shorter than 5? Here's my 5 right here. I can actually go ahead and write 5 really quickly. And I'll go ahead and group that. So here's my 5. What happens if the in-between side is less than 5? We could think if it's 3 or if it's 4. I could even like draw little lines and go ahead and get us those illustrations. Let's choose 3 as an example. So what if it's less than 5? And I would bring this 5 over and try to connect. How many times could this 5 connect? Just once, right? And I could swing it, right? I could have some fun with it. Not that one. Where's my side? There he is. I could swing him, and I could make 1 work, right? So that's one way of putting it. 1 solution. 1 solution would be true if angle or side B is less than 5, right? So 1 solution, I could say B is less than 5. Or equal to, what happens if B is equal to 5? 5 and 5, yeah, it'd be like an isosceles triangle. It would just be once also. Okay, so greater than or equal to. Sorry, if B is less than or equal to 5. If 5 is greater than or equal to B. But don't we still have, oh stink, 2 solutions and no solutions? Okay, so hold on, going back to our picture. 2 solutions. All right, what's true if B is instead, let's go a little bit bigger than 5. So let's do 6. That's a pretty good experimental way of doing it, right? So what if we keep going and we go to 6 now? All right. What's going to happen with the 5? It's going to swing? But I could make it work one direction, right? But not just one direction. If this is 6, can't I also, because I could extend this side. We know nothing about that side. Couldn't I swing it in too? Now, it's going to be a little rough to swing it in. It's going to be a little tiny weird triangle. Right? But I could swing it in. Okay, so 2 solutions. Oh, that's easy then. Okay, so 2 solutions. I need B to be greater than 5. Wait a minute, what about no solutions? What have we not thought about yet? The right triangle. What if 5, remember? If we think about the right triangle, we know the shortest distance between my angle of 36. How could we solve for the hypotenuse thinking about that other side? Yeah, we could do sine again. But if we do sine of opposite over, it's going to be a little bit weird because we're going to have sine of 36 is equal to 5 over x. We're going to have to multiply by x and then divide. Yeah. But can someone get me that number? What's sine of 36? Well, 5 divided by sine of 36. What's the struggle? We see greater than 5 being like, oh yeah, you can go as big as you want. But if that side gets really, really, really big, what's going to happen to that poor little 5? So hold on. Bigger than 5 and less than. You could be super snazzy and do 5 over sine of 36, or you could put the 8.51 or the decimals. So what's going to happen if B is bigger than this guy? Wouldn't that be none? Because if B is too long, what happens to that poor little 5? If B goes farther than this, suddenly the 5 is going to be too short. Why am I not going to put an or equal to? Can hit. See how the right triangle kind of tells us everything? If we take these pieces of information, set up a right triangle, we know the shortest distance. And so if this side works for the shortest distance, I have just one triangle. If this side is shorter than that, I can swing in and swing out as long as, there you go, swing in and swing out as long as B doesn't go less than 5. Because if B goes less than 5, all of a sudden, well, I can't swing back anymore. I can only swing out. And if B goes longer than this, my poor little 5 is too short. But do you see how that was kind of messy? Whew. Because this was thinking of it like totally towards what we were thinking of it in class. We were being given this and thinking about him. They made you go backwards. Whew. Good thing you brought that up, Kyle. I heard Tony and Adam say there might be a couple more that we should go over tomorrow that were kind of tricky, but for right now, some of you need to finish trying homework, yeah? We have our area formula, so we're totally ready to go. I'm going to delete this page even though it was spiffy and all, because it was just for use of that example. There were a couple other examples that we could have done, but for right now, let's just get law of cosines formulas in, which to some degree is kind of easier until it starts to try to have you think through the ambiguous case with law of cosines. It gets a little messy at the very, very, very end. But I want you guys to realize we're still talking about non-right triangles. Right triangles, we'd use trig. We'd use Pythagorean theorem to solve, like Johan said yesterday, for all the missing stuff. To solve for all the missing stuff. Where trigonometry just by itself, SOHCAHTOA CHOSHCAHTOA, is not enough. Law of sines says I work really great if you're given 2 angles and a side. I'm a little trickier when you're given 2 sides and 1 angle. That whole ambiguous thing. Law of cosines says I'll work really great, do you guys see? When you give me at least 2 sides. Law of sines, I work really great when you give me at least 2 angles. Law of cosines, I'll work really great if you give me sides. Guess what, guys? Law of cosines? Plug and chug. Wait, but there's 2 different forms. Hold on. The left side says you're missing a side, and the right-hand side says, hey, rearrange me if you're missing an angle. Bye, cool kids. I'll see you later. This homework isn't due for law of cosines until Friday. Have law of sines ready tomorrow. Later, Gators. Yeah, I'll be here for a bit. Bye, see you guys later.
Today, coffee?